Hello! In this video we're going to look at one question with the natural logarithm, as you can see there, one question on exponential functions, and also another one with conversions from exponential to linear form. So I've just putting together our question here using our laws. So we have our basic 3 laws of logarithms. And in there I've used the power rule, and we've subtracted as well. And once you have ln on both sides, of course, they cancel out. And now just multiplying across, or multiplying by x on both sides if you want. Expand brackets, simplify. And you'll notice that we have to give our answer to 3 decimal places, which tells us something about that question. So we're going to use our quadratic formula. So minus b plus or minus root b squared minus 4ac all over 2a. And plug in your values. So our value of a is 1, b is minus 3, and c is minus 1. And of course you'll get 2 answers. Let's just fix that up. And 2 times 1. So we'll end up with 3 plus or minus root 3 all over 2. And we have a positive value of 3.303 and also a negative value. And the negative value, for our purposes, does not exist. So fairly basic question, perhaps, with basically just the 3 laws. So power rule and adding and subtracting. And another question now, we're going to take logs on both sides. So this looks quite complex when you see these, not for the first time, but when you're doing them in class. This is a little bit more expansive than some of the questions you see in the book, for instance. So power law, bring down your 3 minus 6x, and then we have 4 times 5. So again, our addition rule, we're going to add them. Brackets around. Now we're going to expand brackets. I've got another power rule there, so minus 2x out front. And the ln 5 or ln 5. From here, I think just get our x's on one side. So you'll see I've moved a few things, or cancelled on both sides. And we'll get x and factorize it out. So we end up with ln 4 minus 3 ln 8 divided by the 2 ln 5 minus 6 ln 8. Which I'll write down now. Get that line underneath. And our answer, as I've done on calculator, is 0.5. 0.524 to 3 decimal places, as stated. All right. I think we would agree that it would always be easier to interpret and to find values on a linear graph than a curve, just generally as an idea. So there's this neat little twist, a little trick, where we can convert to, like from the x and y grid, we'd say, the Cartesian coordinates is what you're used to. You can use a semi-log version, so you'd have like ln y and then just x, or you can have a log-log graph where you're just going to have the 2 variables ln y and ln x. In this example, you'll see it's a semi-log, and it can be polynomial or exponential, and it's just a way of converting something into a simpler form, essentially. So let's have a look. In this semi-log question, we've been given an equation. So ky is equal to e to the cx. And I've already highlighted the variables for x and y. So we're going to take logs on both of these. So ln ky is equal to ln e to the cx. Now ln e is equal to 1. To just cx. And again, just using our addition rule there on the left hand side. And now I'm going to rearrange. So what you're doing here is you're making it appear, so linear form, y equals mx plus c. So ln y, there is our y, and mx plus c. So we'll sub in one set of values and then the other. And we can do this simultaneously. We have a minus ln k, so that can cancel out on both of them. So just subtract there. Or, yeah, just subtract. 2 minus 1. And we have 1.838 equals 2.3c. C is equal to 0.7991. So that's one value done. Plug back into 1. So we find ln k. So ln k is equal to, subtract them, 1.865 I've got. So ln k equals that, so k is equal to e to that. So e to the 1.865 is 6.5. So k is 6.5 and c was 0.7991. And we found those values, and we did it correct to two significant figures as well. So they were 3 questions from 2023 and 2024 on logarithms and exponential functions, just for your extra practice in grade 12, Pure 2, Cambridge Mathematics.